Welcome back. In this session, we are going to understand Kubernetes architecture. Now you may be thinking, why do we need to understand Kubernetes architecture? Now let's imagine you have sent a request to the Kubernetes to create 3 containers. So Kubernetes will figure out where to run them, how to balance the load, and if some container crashed, it's going to replace it. And you not need to log in and fix this. But how does Kubernetes do that? That's where Kubernetes architecture comes in. Because Kubernetes has different component and they play different role to make sure everything's working as expected. Now imagine if XYZ reason one container is not running. Now you need to look into that. Then how do you understand which part of Kubernetes is not running? Which part of Kubernetes is not working as expected? So it's important for you to understand this Kubernetes architecture, its different components, and which component do what. To understand those component roles. That's why understanding Kubernetes architecture is important for you. So let's start with looking at helicopter view of Kubernetes architecture. So Kubernetes is built around two main zones. First is control plane and second is the data plane. Yes, so control plane is the brain of Kubernetes. This control plane, as name suggests, so this is control entire Kubernetes cluster. That's why it's said brain of Kubernetes and is do thinking part of it. So control plane do thinking part of it. So when you say you need to create the 3 container, then control plane say, okay, got it. I got the request. I will schedule them across the node, watch them and recreate them if something will goes down. Now where control plane will create this container, that's where data plane came into the existence. What is the data plane? Data plane is the, sorry, let me go back to the previous screen. So control plane is the, sorry, so con- so data plane is the worker of Kubernetes. Yes, so these are workers of the Kubernetes. And you also see this is called worker node 1 and worker node 2. So this is where the container going to runs. So when we say I need 3 container, so control plane going to make the decision and going to make sure 3 containers are up and running, and where it will run, so this will run on the data plane on the worker node. So at high level, at the broader side, we have two bigger component. One is the control plane, another is the data plane, and data plane is also called worker node. Now how do we send request to the Kubernetes? So we have two way. One is the UI, another is the CLI. In this section, we are going to mostly focus on the CLI. For that, we need a CLI tool. So Kubernetes gives a tool called kubectl. So using this kubectl, we are going to send request to the Kubernetes using the CLI to the control plane, and control plane going to create the container for us. And also using this kubectl tool, we are going to manage this Kubernetes cluster. We will be installing this tool in the upcoming session. Well, now let's go ahead and see what is inside the control plane. In control plane, we have the 4 component. First is API server. So API server is front door of control plane. So as a user, when we want to send any request, then we send a request to the API server. As name suggests, this is the API, and this is the public component of the control plane. So this is publicly available, and that's where as a user we interact with the control plane. So when we say we need a 3 container, then our request come to the API server. What API server do? API server validate our request and send this request to the different component of the control plane to do the job or take the action. So API server accept the request, validate the request, then it send request to the other component of this control plane. Now next is the etcd. etcd is the source of truth of Kubernetes cluster. Yes, this is basically a database where we store all information, we not where Kubernetes store all information about the entire Kubernetes cluster. Yes, how many containers are running, how many containers need to be running, what is the configuration of these containers, where is the secrets, number of nodes, namespace, everything. So etcd store entire cluster states. This is high available key value store where Kubernetes store all the information. In other words, we can also say this is long-term memory of Kubernetes. Next is the scheduler. Scheduler decide who runs what. We know we have multiple worker nodes. That's where our container going to run, and this is decided by scheduler. So as name suggests, scheduler decide container going to run on which nodes. It checks the number of available nodes, how much CPU and memory is available on the which each node, and which node is best for running this particular container. So this decision making is done by taken care by the scheduler. Now when we say we need the 3 container, then scheduler decide maybe these 2 container or first 2 container will go on node B, whereas container C that will go on node A. So scheduler task is doing the matchmaking and making sure these containers are equally distributed on the nodes and they are getting their required resources. Now last is the controller manager. Controller manager is keeping track of everything. As name suggests, this is keep track of everything, and this is watchdog of the control plane. So when we say we need 3 container, then this data get stored in the etcd, right? So if one of the container goes down, then controller manager keep close eyes looking the data from the etcd is go ahead and create one more container. So this is actually makes sure actual running states of the containers and the nodes. So controller manager don't do these things alone. It has the different controller. One of them is the replica set controller. If you remember, I said self-healing part is done by the replica set, right? So there is a replica controller that maintain the correct number of container. There are deployment controller, so that makes sure rolling updates and rollback if needed of our containers. As there are also node controller, job controller. Yes, so all those controllers fall into the controller manager, and this is taken care by the controller manager. So these are 4 important components of the control plane, and they all work together to make sure a container is working as expected. Now let's go ahead and see what is inside the worker node. In worker node we have three components. One is the kubelets, then Docker and kube-proxy. Now let's understand this one by one. First, start with the kubelets. So kubelets is the agent that's run on each worker node, and this is the agent and this agent is bridged between the control plane and the container runtime. So here container runtime is the Docker. So basically Docker this component, again I'm going to talk in a moment, so this basically go ahead and create the container. But how it will create the container? So when control plane send the request, then this request come to the kubelet. So kubelet is the bridge between, as I said, this is bridge between control plane and the worker node. Is accept all the request, then it forward this request to the other component of the worker node. Now let's understand with the example. When we say we need three container, then our request goes to the control plane, and control plane scheduler decide on which node this container going to be created. Then that request come to that particular node's kubelets, and kubelets talk to the container runtime like Docker or containerd that's actually create the container. Then again kubelets regularly checks and makes your containers are running or they are healthy. If something goes wrong, if container crashed or misbehave, then kubelets go ahead restart it or also report it back to the control plane. So again you see this is makes you this is healthy, this is running. If not running, getting crash, it starts. If again persist, anything, if persist, if not persist, and again all these reports, this is sent back into the control plane. So kubelets is the main agent inside the worker node that do the heavy lifting of running the container. Now next is Docker. So this is not Docker, this is basically container runtime, and this is where our actual container runs. So Docker is, we already know, so this is used to create the container, and we can also use containerd. So Kubernetes also use containerd. Containerd is the new and lightweight alternative of the container, and it also works. This container runtime could be other containers platforms as well, but as of now here we are talking about Docker and containerd. So Kubernetes directly don't create the container. So Kubernetes send the request, and this creation of the container is done by taken care by container runtime. So whether this is Docker or containerd, that takes care of the container creation. And now this do heavy lifting of container creation. So just go ahead, pull the image, run the container, start the container, and also make sure this is running on the right port. And that's where our actual application runs. Now last component is kube-proxy. Kube-proxy is networking gatekeeper of Kubernetes. In a real application, it's not enough to just run a container. They need to talk to each other. So frontend need to be talk to the backend need to talk to the database, or maybe other component need to talk to the other component. So that's where kube-proxy comes in. This is responsible for routing traffic to the right container inside the nodes. It takes care of the networking rules like IPVS, and makes sure when we are doing the load balancing, then a request goes to the right container. So all together, kubelets, kube-proxy, and container runtime, here we see the Docker, makes your worker node is running, accepting the request, and making sure containers are running. Well, now we have understood architecture of Kubernetes. This is the architecture of the Kubernetes, where we understood these different zones and different components within this. So if needed, please watch this couple of times, because understanding, knowing these different components is responsibilities important for you. Thank you so much. See you in the next session.